Okay, to start off today we are going to look at how we can graph quadratics, and we're only going to focus on standard form for this particular one. First thing we need to do is look at what is a quadratic function. And a quadratic function is a function that has an x squared term in it. So our standard form looks like y equals ax squared plus bx plus c, where your a, b, and your c will actually be some form of numbers. And our only requirement is that a cannot be 0, because if a were 0, then our x squared term would go away, which would then make it not be a quadratic function. When we graph quadratics, we will be getting a parabola. And our parabolas have two general shapes. The first one is when they open upward, and that's kind of our standard parabola. Our parabolas can also open downward. But anytime that we are dealing with quadratics, we're going to have this shape of a parabola. There are several key features that we have when we look at parabolas. Two we're going to talk about now are the vertex and the axis of symmetry. The vertex for a parabola that opens upward is the lowest point on the parabola. When you have a parabola that opens downward, your vertex is actually the highest point. And the axis of symmetry is very closely related to your vertex, because your axis of symmetry is a line that goes right through your vertex. And if you think about what symmetry means, like in art, it means what's on one side is mirrored on the opposite side. So our axis of symmetry actually cuts our parabola right in half. So whatever is on the left side is mirrored exactly over here on the right side. So our vertex is either the lowest point or the highest point. And then our axis of symmetry is a line that goes right through your vertex. What we're going to look at now is what different numbers do to our graphs. So first thing we're going to do is look at the parent function, y equals x squared. This is the most simple, basic parabola that we have. And here's a picture of what the graph looks like. As you can see, it's curved like the parabola should be. What we want to do is we want to look at what happens when we put 0.25 in front of that x squared. And as you can see, our parabola, when we have 0.25, comes out like this. So look at that one and then compare it back to our parent function. Next, we're going to look at what happens when I put a 3 out in front of the x squared. Okay, when I put that 3 out there, look at what happened to your parabola. So here's the parabola that just came in when we had a 3 out in front of by our x squared. So compare that to the other two. Okay, we're going to switch gears a little bit. We're going to look at what happens when I put a negative in front of there. So I've graphed negative x squared, and as you can see, the parabola has jumped down here. Now we're going to look at what happens when I put a negative 2 in front of there. And here's the graph we just got when we put a negative 2. So be thinking about, what does the number out in front do to my parabola? Our next one and our last one that we're going to look at is what happens when I put negative 0.5. So when I put that graph in here, negative 0.5 comes out here like this. So now what you want to do is you want to think, what effect does A have on the graph of the quadratic? And remember, our standard form is y equals ax squared plus bx plus c. So right now we're only looking at what does the letter with the x squared do. So what effect does this number have on your graph? So think about that for just a second. Hopefully, what you noticed was that if a is positive, that the parabola opens upward. And when we had a turn into the negative, our parabola flipped upside down and opened downward. Next thing that you hopefully noticed was how it changed how wide or how narrow it was. And what happens is that the graph is going to be wider if the absolute value is less than 1, and your graph is going to be narrower if the absolute value is greater than 1. Now the reason we have to have the absolute values in here is because the sign determines whether it's up or down. It's actually the number that determines how wide or how narrow it is. So the absolute value there is telling you ignore the sign and just look at the number. Alright, two important things is that when we are in standard form, we're going to have to find the vertex. Need to star this right here. So when we're in standard form, the x-coordinate of your vertex is always going to be the opposite of b divided by 2a. This right here is a key equation that you will need to use over and over and over again. And this is for standard form. Now if you want to think about the vertex is an xy ordered pair, this is a formula to get us the x. So you've got to think about what are you going to do to get the y value of that. Well, once you get your x value, you can take it and you can sub it back into your equation and calculate it out, and it will give you its partner. It'll give you the y value in return. The next thing is that our axis of symmetry is always the vertical line x equals the opposite of b over 2a. Now the reason that these two formulas are the exact same thing is because of how your axis of symmetry and your vertex are related. If this were at the point x equals 4, our axis of symmetry is that vertical line x equals 4 because it has to go right through the vertex. So that's why your vertex and your axis of symmetry will actually be the exact same formula, is because they refer to the same x value. Alright, we're going to practice graphing some. So the first thing I want to do is I want to kind of look at my graph and get an idea in my head as to what it should look like. So I look at this 2 and I know that my graph had better open upward because it's positive. And I know that since it's a 2, it's going to be just a little bit narrower than my parent function. Now when you're doing the graphing, after you get an idea of what it should look like, you always want to find your vertex first. That is a must. So if you use that formula we just talked about, it says our x-coordinate is equal to the opposite of b over 2a. Well, now our standard form is where we get our a's and our b's. So the opposite of b. b is the number that's with my x value. So if I look here, b is negative 8. Well, my formula says I need to take the opposite of b. So the opposite of negative 8 would be positive 8. Then it says I need to divide that by 2 times a. So I look back at my standard form here, and a is the number with x squared. So according to my equation, a is a 2. I can simplify that out, so I actually have 8 divided by 4, which gives me a 2. So my vertex has an x-coordinate of 2. I need to find the y-coordinate. So to find my y-coordinate, I look at my equation, and it says y equals 2 times x squared. So I'm going to go and plug my x value back in there, in all of the x's. And then I can go ahead and evaluate it. So 2 squared is 4. 2 times 4 is 8. 8 times 2 is 16. And then we can just add from left to right. So 8 minus 16 would be negative 8. Negative 8 plus 2 is negative 6. So my vertex is at the ordered pair 2, negative 6. And that's going to be the starting point for my graph. That is one point you have to have on every single graph you do. So I'm going to come over here and I'm going to go ahead and plot that point. It's not very straight. Okay, so I'm going to go over 2 and down 6. And right there is my vertex. Now I am going to do a table of values to find the rest of my graph. So make yourself an XY chart, and you're going to use your vertex to help you pick values for x. Since my vertex is right here where x is equal to 2, I want to pick 2 x values that are to the right of my vertex and 2 x values that are to the left. So for my values to the left, I'm going to pick 0 and 1. And for my values to the right, I'm going to pick 3 and 4. Now I have to go through and I need to find the y's that match up with each of these x's. So to find my y values, I plug my x's back into my equation. So if I just do the first one here, plug in 0, I would have 2 times 0 squared minus 8 times 0 plus 2. Go through, simplify that all out, and I get y equals 2. So when x is 0, y is 2. Then I'm going to do the same thing for my value of 1 here. Instead of having zeros in here, I'll have 1s in here. Multiply that all out, and 1 squared is 1, times 2 is 2. 8 times 1 is 8, so I have 2 minus 8 plus 2. Simplify that out, and we end up getting negative 4. So when I have x1, I get y to be negative 4. You can go ahead and do those same things for the 3 and the 4. Okay, when you plug both of those values in, hopefully you got negative 4 back when you plug the 3 in, and hopefully you got a 2 back when you plug the 4 in. Now you can come over to your graph and you can plot those points. So I'm going to go ahead and plot the point 0, 2, and 1, negative 4, 3, negative 4, and 4, 2. Once you have your points plotted, double check to make sure it fits what we had decided before. It looks like it's going to open upward. It's definitely shaped like a parabola, so then you can go ahead and connect them to make your graph. So for the graphing here, we started by finding the vertex, and then we did a table of values.